Hello everyone, my name's Lee MacDonald. I'm a software engineer and I'm the principal and founder of Data Vanguards. We run a boutique data practice that Lara's done a better job at describing what we actually do. So I'll leave it to him. So I've been on a bit of a journey for the last 4 years, delving into the world of streaming and real-time OLAP. And I could best classify it as a series of small car crashes, learning the lessons the hard way, getting the scars, a little bit of PTSD, but it has been very, very enjoyable. This journey started with a local-based company, family zone when I was with them, now called Korea. They had a pretty gnarly workload. We were streaming anywhere between 8 to 12 terabytes a night, in the middle of the night, yes. Pumping that to an OLAP engine and then trying to deliver analytics to a couple of thousand different customers. So you can imagine that was fun. So I spent most of my evenings or middle of the mornings getting woken up very rudely by some PagerDuty alarms that still haunt me today. So moving out of Korea into Amazon Web Services, I was very lucky to get the opportunity to actually work inside of the engineering org in AWS, which is no mean feat considering I'm one of the most isolated cities in the world. I'm based in Perth. And that's where I got most of my reps when it came to streaming. That's where I really got up to speed. Streaming concepts, technology was really coming strong. Apache Flink was firing. It had won the battle against Apache Beam, Dataflow. And it was really exciting. Loads of streaming workloads, but we still hadn't really landed the real-time OLAP. The traditional OLAP engines just weren't able to cut it. High concurrency, query latency, they just really struggled. So coming out of AWS into my own practice, I got straight back into streaming workloads because I didn't have enough car crashes, enough stress in my life. And this is why I'm here today to talk to you, because I had a bit of an epiphany, a bit of a realization working with VLAN, my customer from this year, and I'm going to share this epiphany, this realization I had. So before we get into it, this was my biggest bugbear. As I've been on my journey in streaming, streaming had evolved. It was getting really good. We were able to do some really cool things. Capability was rising, so loads of people were getting involved, committing to Apache Kafka, Apache Flink. But right at the end of the stream, because the OLAP engines couldn't cut it, we couldn't deliver pattern flexibility to highly concurrent workloads, we ended up splitting. So we broke the Kappa model, which was just awful. Jay Krebs never would have been happy with us. And I found myself doing this more and more with customers. Had to get really clever at how we pre-aggregated data to get sub 100 millisecond response times. So this was just really, really dirty. It was putting me off what I was doing. And it was all because I had this core belief that was shared to me by a man in the front row here, PyTherm. So we'd moved past cap theorem, which is consistency, availability, partition tolerance. A lot of really, really clever engineering had engineered around those corners. So we'd moved into a new realm. In 2019, this phrase was coined. We had to pick from these three characteristics of a database. We could only have two. So at the very top, we had pattern flexibility, so the ability to support analytical style queries. We had efficiency, queries that would run in less than 100 milliseconds, and infinite scale. And that was it. And this was the challenge we always had. We always had to pick one. We couldn't have it all and eat our cake. So I'm here today to talk about putting this to bed and moving beyond it. So first off, I'll do a good job. I'll try to break down all the buzzwords I put in my title. Real-time OLAP. Who understands the term OLAP in the audience? Cool. Data engineers. More people understand OLAP than run. That's good. And real-time. I think everyone's familiar with real-time. It's whatever you perceive it to be, but generally anywhere between a couple of milliseconds out to 10, 20 seconds, sometimes minutes, depending on where you are. Next up. So it's really important to set why we need real-time And this is an argument I had regularly. This was a belief. Because of pi theorem, I'm going to blame pi theorem, it wasn't me. I'll let everyone read it, I'll have a little drink of water. So that was me, all calm, down the bottom, not really. Just describing to my lead engineers and product owners that it's an OLAP workload. You're never going to beat 1 second. That's just life, man. Just get over it. We need to engineer around the edges. We need to design better. We need to be clever at how we pre-aggregate data. Use a couple of databases. What's an extra database to total cost of ownership of a stack for a product company? It's not that big of a deal. Well, that was a lie I told myself for too long. And it's safe to say that I don't believe this anymore. I've evolved as a human, as a data engineer, as a streaming person. So I'm going to talk a little bit about why speed matters. And I'm going to give the lead engineers and the product owners some arguments, if you ever meet an old me, to stick it in my face. So it's been no secret for a long time that latency has always mattered. So hyperscalers found in the early noughties that latency cost them a huge amount of money. So Amazon published a report. Every 100 milliseconds of latency cost them 1% in sales. That is just incredible. I wouldn't imagine what it's like today, but I'm sure that they keep those, now that they're a public company, well, they're public like them, but I'm sure they keep those reports well hidden. And Google, similar experiments, significant drop-off in user search, and that trend continues if you continue to introduce latency into someone's experience over long periods of time. So being the nerd that I am, I always like to fall in a few rabbit holes. I kind of wanted to understand it a little bit more. So I've done a little bit more digging, and I landed at the human visual system. This is how I described it to myself. The human brain actually has about half of its capacity designated to the visual system, which is insane. So you can respond to visual stimuli in as fast as 13 milliseconds. Which is pretty incredible. What's very scary for us data engineers is once you breach that 13 milliseconds, our visual system starts to degrade, which is insane. Right up to 100 milliseconds, where you actually start to become cognizant of it. And your brain then flips from leveraging all of that oomph, the L2 cache, if we're going to kind of map it back to a techie term, and it starts to anticipate what it's seeing. So from a scientific perspective, this was my analogy, and this is why I really started to worry about speed and putting OLAP queries that were taking 20 seconds in front of customers. And then on the other side of the coin, which is something that I learned the hard way, data freshness also matters. And if you're not designing to be able to ensure that your data is fresh at that real-time need in milliseconds, seconds, you're going to know about it. And it's all because of this simple equation, time value of data. And this is everywhere. And I'll use one example. You can imagine you're a security firm and you're looking after some enterprise's security, and you find out about a security event in 5 seconds and you act. That's pretty awesome. That's very valuable. But on the other side, if you find out 5 minutes later, the intruder is in, they've hidden themselves, they're gone, that could be the end of the company. The difference in value between data in 5 seconds and 5 minutes is huge. It's massive. Cool. I don't feel so preachy after listening to Joe's last couple of roundups, but I'll get into some of the concepts that I've kind of wedded myself to from these 4 years of experience with these pretty large streaming workloads. First principle thinking. And this is, I suppose, pretty simple. I'm not stating that everyone should understand every single sort algorithm or all of the different distributed algorithms. I'm just saying that when you're designing or looking or using a solution, at least understand these 3 key principles. Understand where your data is stored, how it's stored. Is it compressed? Is it in object stores? What disk is it on? SSD, HDD? How's it coming together? On the flip side, networking is just important. How is the data getting from storage to compute? And then back to the user. Because you can fall in some rabbit holes if you don't fundamentally understand what's happening there. And then the most important thing, understand what sort of compute you're using. I suppose a data engineer, if you were to try to classify what a data engineer does, they mostly make trade-offs around where you pay for your compute in your data pipeline. which is super interesting. These arguments come up, ELT versus ETL, a materialized table versus a view. The argument goes on, and we're seeing this proliferate. The more we have this unification of data platforms, the more convoluted this gets, and the harder it is to actually see what's happening, how the computer's working and how the system pulls together. And then my final point before I get into a specific use case is access patterns. Something pretty simple, but I think a lot of people forget to do it with any due diligence. So you kind of do it in the back of your head, especially if you've got a couple of years experience. You're like, kind of understand that these queries are going to be hitting this database I better design. This is my data model, these are my order, this is my order by, this is my indexes, this is how I might compress it. Pretty simple idea, but from dealing with 20, 30 plus customers coming in, re-architecting solutions, it's amazing how much like small mistakes people make by not looking and understanding what the actual access pattern is. How are we writing to it? How are we reading? Pretty simple stuff, but really, really important. So I want to talk a little bit about a use case. This is where I came to my little epiphany. And the customer is a pretty interesting one. They're the media partner for professional cycling teams in Europe. Can I get a hands up for the amount of people who actually cycle? Do we have any mammals in the room? Oh, we got a few. Yeah, I'm a mammal. Weekend warrior. So VLAN, their core mission is to better engage the 565 million fans they have globally, which is pretty big addressable market. And their goal is to monetize the sport on top of that. So we engage and monetize. The world has never been more distracted, and fans have got so many sports, so many activities, so many hobbies. It's really hard to keep them engaged. And let's be honest, cycling is not the most exciting sport to watch. Unless you like learning about chateaus in France. It can be pretty painful. So the brief was pretty simple. Build me a live data platform that can enrich the fans from a digital perspective. Fans' experience. So the goal was to consume live data, push it through our dynamic live race data platform, and feed enriched experiences through different channels, through broadcast, through the web, and through mobile, to reach our fans. And I met them at a couple of different stages on their journey for this goal. So they were lucky enough to go through a series of incubators, innovation incubators in Amazon, and I actually was part of one of those labs. And then on the other side, they flipped out. And after I stood up data vanguards, they came and asked me to operationalize the prototype that they'd ended up with. And I was really excited. I was like, this is cool. Streaming's my bag. What could go wrong? And it was easy. They only wanted one use case. I was like, cool. Let's give this a whack. They purely wanted an insight feed that was aggregated and windowed, just beamed straight to broadcasters, and we had to beat 20 seconds. That was the goal. We needed to be faster than the broadcast so that we could overlay it and develop some analytics alongside it. Along with that, they said, if you could potentially do something around race highlights, segments, you might be able to enable us to craft a better story. We can rank riders over specific segments. That'd be pretty cool. I was like, cool, let's get into it. So a quick look under the cover before I start talking about the little journey we went on. This is a simplified view of what the pipeline or the platform looks like. We got an ingest cluster listening to WebSockets. We got a stream engine doing some windowing, managing some of the event time constraints, doing a little bit of cleansing, small bit of enrichment, and then we'd fan out to an insight engine and a highlight engine that was built inside of Lambda. And these were isolated, dynamic, abstracted to CDK, so we could add as many insights or as many highlights as we wanted. It was pretty cool. And then on the far side, from a consumption perspective, because we were only feeding broadcasters and internal analysts, we just had WebSockets. We'd shunt the data to every highlight and insight in real time, and then we had DynamoDB, simple key value store. So we had an early win. We deployed the platform on time, just in time for the Tour of Britain. 70 cyclists, a couple of predefined segments, which turned out to be a bit of a winner. We were really lucky in regards to how we kind of set those predefined segments early, and we got some really viral moments from it. And we'd met all of our non-functional requirements. Speed was on point from a latency perspective. Freshness was anywhere between 3 to 20 seconds, depending on the insight. We had 3 different insights. Some of them were computationally more expensive and doing larger windows and more enrichment. So it was a win. I was happy. It was cool. And this magic little feature was starting to engage more and more fans. Broadcasters were interested. VLAN themselves were interested. And this is a screen of the, trust me, I didn't put this in front of users, by the way. So any UX people out there, don't worry. This was for the analysts crafting the segments. And you'd see they'd draw where they wanted the segment, and that was just fixed in. And we'd compute that segment in real time. It was really cool. So as we rolled into the October Classics, the races were larger. We added a few more segments, and we were thinking, what could go wrong? Surely there's not another wall around the corner. I'm not going to crash this time. I did. The segment feed died. So we had to do a bit of pivoting. Obviously a live race. This is not very nice. These live races from a stress perspective, it was not fun. Broadcasters shouting at you, analysts shouting at you. And I couldn't fix it on the day. So we set up late into the night, and we were like, I wonder what happened, because we couldn't be compute bound. The lambdas were tuned up. That was definitely not the case. It turned out to be a tricky little limit, passing messages between step functions. And inside of this inside engine, you can see that there's a series of different lambdas that pass off, and then we fan out to different sinks. So it was this message limit that caught us. I was like, cool, quick fix. It's not gonna bring us very far, but we added some compression, and then we cached whatever we couldn't compress. And we got through the race. So it did leave us with a bit of a problem though. We were like, the only feature that was really engaging fans was never gonna scale. We couldn't scale it. It fundamentally couldn't take it to market and evolve it past a predefined segment. So we had to go back to the drawing board with segments. And this is where we jumped into my little flow, my little process. So I like to always ideate and make sure that user stories are quite clearly defined. That helps me derive my functional and non-functional requirements. And then from there, I can dissect the access patterns, and then we get into solutioning. And it can be a bit pedantic, but this is from my AWS days. We used to do these 2 or 3 a month. And if you weren't process-driven, it would take a long time. So this is, I suppose, from practice, looking at many, many different architectures. I just found this worked. Reduced the amount of mistakes, helped me think like a scientist, derive hypotheses, test them, and then come back when the hypothesis didn't work. So when we actually flipped it and we stopped thinking about the analyst and the broadcaster, we said, what does the fan actually want out of this segment? And this is where it got really scary, I'm not gonna lie. We had over 565 fans addressable, but reality was we only had in the previous app about 25,000 active users on any given race. It's still pretty big, over a 5 to 6 hour window. We had a large number of riders. We didn't know who the fans liked. We couldn't write this up front. We didn't know beforehand. We didn't know what teams they liked. We didn't know whether they liked climbs or whether they liked sprints or whether they were interested in the young white jersey race or whether they were interested in the climber's jersey. And the segments, that was another problem. I was just off the scale. Like, some of the races are 270 kilometers, 280 kilometers. You're never going to be able to predefine them. And you're never going to know when something interesting happens inside of these races. So we kind of really were unsure about what we would do. Drafted up loads of cool ideas. I was going to build a microservice. I was going to learn Rust. It's cool. But I thought I'd roll back and I'd stick to my database days, and I was using ClickHouse for another type of workload, a log cybersecurity. So I'd seen how powerful it was with large volumes of data, huge throughput, scouring unstructured data, all of its search functionality from a text perspective. And I was like, cool, but give it a swing. It's like, it'll take me a couple of hours to put a little POC together. We had a little bit of data in the database from a couple of races. So I stood up a dev cluster. I was too lazy and too cheap to stand up a production cluster. I realized that pin at 24 gigabytes is wrong. Anyway, it was 8 gig RAM, 2 nodes, and 1 vCPU, 4 CPUs available for each node. We had 2 gigabytes of data in there. There's about 20 races. We ran our benchmark across 3 races, 3 riders, and we were simulating a series of summary statistics over different segments. And over a 5-minute period, I was able to generate 113,000 queries. Sorry, 1 minute, sorry. 113,000 queries. I had a QPS of 1,891 queries, which is just insane for a data warehouse. I didn't believe it. I've done this benchmark like 50 times. I was like, this isn't real. And a P90 latency of 70 milliseconds. It's nuts. So then I extended and I was like, is it even reading any data? Is my query working? I was like, oh, it is. There we go. We have a P50, 56 records, which is normal. You're kind of looking at a couple of kilometers, summarizing statistics and rolling it out. But at the larger end, we had some significant scans, 1 million records. It's not big data, it's small data. I'm not gonna lie, I thought the data was gonna be too small because I was used to using ClickHouse for terabytes and petabytes of data. But I suppose that really opened up a few doors. So then we started to think that, what if we didn't need to pre-compute? What if we could do it on read? What if we could give the fans the ability to craft their own stories and share it with other fans? And you can imagine that got everyone excited. Add in historical races. We could add in other metrics, fan profiles. We could do a lot more. Now that we had a database that we'd pocked and we trusted that was going to be able to scale to 25,000 concurrent users, this opened up many more doors. So we went all in. So we pretty much came up with the hypothesis. We stated that stories and data was the way we were going to engage and monetize the sport moving forward. Crafted up some designs. We've got some things in the pipeline, not quite across the line, so I can't say anything, especially because we're being recorded. Get myself in trouble. But that was what we were trying to do. We were trying to give the fans the ability to craft their own story, Strava-like, and then people could go in and engage, comment, critique, share their own opinions, abuse other people for their opinions. It's the usual thing you see on social media. And so we recrafted the user story. Apologies for the amount of words. But from the user story, we defined our acceptance criteria. I then done the pretty anal thing. I pulled out my functional requirements, my non-functional requirements. And that brought us into describing and defining our access patterns. So, right, it's actually a pretty simple workload. I was just a little bit worried about how small the writes were, because ClickHouse works on the concept of a part, and if you got too many parts, it's just one of those no-goes. But we defined the write operation up characteristics of the data, highly structured, monotonically increasing time series, small number of dimensions with a larger number of measures, and we had a little bit of late arriving data because of the pesky internet and the connectivity in some of these places. Cool. So as we move through, on the other side, this is where it kind of really gets a little bit hairy. So we defined our read access patterns and we got into it. Concurrency was a thing. We really wanted to set a benchmark of 25,000 queries. It needed to be at least 200 milliseconds, if not 50. And once again, same characteristics. And from a query perspective, we were just doing group buys, aggregations, simple summary statistics. And we knew this wasn't going to work. Like functionally, it just wasn't going to work. Even setting predefined segments, it was just impossible. So we thought, let's be clever. Oh, this stupid clicker, sorry. It only goes forward. There we go. So we thought we'd shift around our pipeline, we'd do it on read. So trusty old me, back to my first principles. I wasn't just going to trust it on face value. I needed to have a little look at what was happening under the cover, because that speed is just insane. I was like, surely it's not going to scale. Surely this isn't something that will work. Lo and behold, it will. So ClickHouse itself, this is the cloud architecture based on top of object storage, so infinite scaling. Its compute layer has got a multi-cache system built in C++, so it's incredibly powerful from a concurrency perspective. And one of the nuggets that I found was 1,000 concurrent queries per replica. And you can also scale this cluster horizontally. So theoretically, there is no limit. There's no limit in concurrent queries, which is incredibly powerful. I was sold. I still had to dig a little bit deeper and just tick off the boxes. It's like write throughput. I was like, I'm a little bit worried, but then I found async inserts, which is a really cool feature on ClickHouse where you can actually buffer on the server side your writes so that you're not flushing through to disk really small splintered amount of data, which is one of big tables, HBase's real problems. I was like, that's really cool. Concurrent queries, we've already answered it. The latency, I wasn't too worried because we'd done a POC. And everything else was kind of rolling in. And I'd done the math. I think it was about 4 terabytes of data based on the historical races that they had and based on adding in all the other measures. So I was like, this is pretty cool. I'm excited. But I was like, why is it so quick? And I was a little bit annoyed that I couldn't find a silver bullet. The answer is ClickHouse is so quick because of its attention to detail. It's designed for speed. It's not just one big answer. These are the obvious things. Obviously, columnar orientated, so we only scan the data we need to scan. Vectorized query execution, which means that it takes the columns and shunts it onto the CPU, which means it's incredibly efficient. It's got a cache. Its data compression is off the scale. They've got bespoke compression algorithms for every single of their own data types. It's nuts. This is like a treasure trove. For anyone who's a big data nerd, just go and read the documentation. It's a fun place to be. Cool. So I'll close out. So real-time OLAP, we've validated that we need speed. We've got a need for speed. We've talked a little bit first principles thinking, and hopefully you can embed that into your thinking when you're evaluating data stores. And then also be guided by access patterns. Don't skip this step. Just spend a half an hour dissecting your user stories. You'll be amazed at how many times you've got to go back to the product owner and go, I don't actually understand how this works because I'm missing loads of things from an access pattern perspective. And we can move beyond PyTorch. Let's put this to bed. It's dead. I wonder who's going to coin the next theorem. The Lee theorem, maybe. I don't know. That'd be actually pretty cool. And that's it. So thanks, everyone, for listening. I'm Lee from Data Vanguards. If you're interested to get down and dirty with ClickHouse, you want to get your hands dirty, there's a series of actual products, outcome-based, we've just launched. That'll help you get started with ClickHouse, design and architecture, get your hands dirty, build alongside Data Vanguards if that's what you're into, and then obviously performance. If you've got some performance issues with any of your OLAP engines, we'll come in and do an assessment, first principle, and we'll give you a direction forward. And that's it.
Thank you, Lee.